What's up, guys? Again, as I texted you, we'll be starting offline classes from Saturday. Okay, so make sure you guys watch all the videos which is supposed to be done, and so that we will be able to continue without any hassle on from Saturday. Okay. Now that being told, today's class we'll be doing the next derivation of straight lines. If you remember the previous class when we did that derivation of straight lines, we only solved one numerical. It was called as the intercept form. Today's class will be solving something called as distance between parallel lines. Okay. So if you watch the previous video, I told there are two things which are important. One is distance between parallel lines, intercept form, and only for backup sake, there's also something called as a normal form, which I'll be doing in the next class. Okay, learn one derivation at the same at one time, more than enough. So distance between parallel lines. So this has the potential of being asked as a direct 5 marker, unlike the previous one. The previous one is more like a 3+2. This is direct 5. First of all, let's try to understand how do we generally represent parallel lines. After this derivation, I was supposed to do a question, okay? The same question I'll take right now for an example. Let's say the equation says 2x plus 3y plus 5 is equal to 0. By chance, this is line 1. And line 2 is almost the same, which means 2x remains as it is, 3y remains as it is, but let's say this is called A, this is called B, and this is called C. The actual representation of any parallel line will be AX plus BY plus C1 is equal to 0, and AX plus BY plus C2 will be equal to 0, which means I'll assume some other number, I'll assume 9 here. So this set will be called as a parallel line. So is this the only example? No. Focus. Line 1, if you see, the value of A, the value of B has been repeated, and only the value of C1 and C2 kept on changing, which means everything is a constant. Okay, there's only one small change. This is one way of representing. One more way is, let's say L1 is given to us as 2x plus 3y plus 5. Okay, and L2, instead of 2x and 3y, it is 4x plus 6y plus, let's say, 9 is equal to 0 is equal to 0. If you only focus on the A and the B part. Don't you think A and B are multiples? Which means if you divide one by the other, you're getting some constant. There are two ways of defining the set of parallel lines. One is the values of A and B for both the lines have to be the same or have to be multiples of each other. So these are the two conditions. I'll repeat them. Two conditions are what? One is the value of A and B has to be the same. If this is not the case, the value of A and B have to be multiples. What not to get confused? With respect to C, C1 and C2 need not be multiples. For example, if you see in the first case here, I took the value of C1 as 5, the value of C2 as 9. Both of them aren't multiples, obviously, because L1 and L2 aren't multiples. But if you see the second case which I took, I wantedly kept the numbers as 5 and 9 itself for C1 and C2, but I changed the values of AB and AB here. A and B are multiples here, but C and D, C1 and C2 are not dependent on each other at all. That's the complete point. Okay, C1 and C2 need not have any relation at all. Okay, so this is the meaning of parallel lines. Two conditions. Both of them are important. Both of them. I can't tell both of them will be asked. That's the logic basically. Now, how do we derive? We regularly draw one reference diagram. It should look like a straight line, unlike my drawing here. Okay, and we obviously make one line meet. But since it's a set of parallel lines, I'll draw two lines. Okay, make sure they look parallel to each other. Fine. Now, what's going to happen? Obviously, since I have no other point as my reference automatically by default becomes the origin, which is always represented by 0, 0 and the letter O. Fine. Now, please focus here on what I'm going to do. I'm going to draw one straight line. I'll draw a dotted line. You draw a solid line. Okay. Why to confuse you guys? Even I'll draw a straight line, but I'll use a different color. Okay. So focus. I drew a straight line from the origin. Okay. From my default point to both the lines. Okay. Not one, but to both the lines. So if you see properly right now, both of them are cutting the lines at 90 degrees each. Okay, at 90 degrees each. So if you see the distance from O to the first line, 1 second, I'll name this as line 1. I'll name this as line 2. So in other language, from the origin to line 1, this distance, I'll represent it to be D1. Okay, similarly, the distance from origin to line 2, I'll represent that to be D2. So what does D1 and D2 mean? The distance between the origin to both the lines. Okay. Now, obviously, this is the x-axis, this is the y-axis. I forgot to mark that. Now, my diagram is almost complete. I'll be able to proceed here. I have a small doubt here. Just focus. There's some gap between both the lines. This gap, don't you think I'll be able to get the mathematical answer for that also? Because that gap is nothing but d2 minus d1. Why? If you see properly, we obviously know that the value of d2 is more compared to whom? D1. So it's always the bigger number minus smaller number. Therefore, this gap, the answer is d2 minus d1. It's important. Now, what I'm going to do, I'll represent the value of L1 and L2 in terms of general things. For example, L1 is nothing but ax plus by plus c1 is equal to 0. Similarly, L2 will be given by the general equation ax plus by plus C2 is equal to 0. Observe both the things carefully. I assume the value of A and B to be same in both the lines. I've intentionally changed the values of C1 and C2. It should never be the same. If they are the same, they cannot be called as parallel lines. Now, we obviously will be learning, there's a formula when it comes to finding the distance. Okay, the formula goes like this. D1, in this case, I'm talking about distance between the origin as well as line 1. Okay, so is given by the formula a, okay, 1 minute. I'll write the formula here first and then we'll try to execute it. This is the general formula. Ax plus by plus c whole thing divided by root of a square plus b square. This is the formula to find the distance to find the perpendicular distance. This also we have one specific derivation which is not required at this point of time. Okay, so this is called as the word perpendicular distance. Why I'm using the word perpendicular? Because the 90 degrees was formed here. Simple, straight to the point. Now, if you see D1 and I'll try to find the value of D1 and D2 right now. But the problem here is if you see, we only have letters and letters and letters everywhere. Okay. Again, one more problem is we do not know the values of A, B, and C. Okay. Fine. But fortunately, we know the values of X and Y. If you're wondering how, don't you think my reference point is always the origin, which is represented by 0, 0. 0 is lying on the X coordinate, which means X. And again, 0 is lying on the Y coordinate, which means Y. So I indirectly have a value for X as well as Y. I do not have any value for A, B, and C. It's fine. So wherever I write D1, don't you think it will make more sense if I write C1? Because don't you think D1 is the distance between the origin and line 1? And according to our assumption, line 1 has C1 in it. Therefore, I change it and wrote it as D1 is equal to AX plus BY plus C1, whole thing divided by root of A square plus B square. What has to be kept in mind? That the value of C or the letter C is always absent in the denominator. Okay, now I'll continue. I'll keep the value of D1 as it is. I'll write A also as it is because I do not know the value. The value of X is nothing but 0 plus the value of B as it is. Again, the value of Y is equal to 0 plus C1 as it is. Whole thing divided by root of A square plus B square. One constant mistake I've done throughout is I've written caps A, caps B everywhere, but my assumption is A, lowercase a and lowercase b. You should not do that mistake. Change all the caps A and caps B to lowercase a and lowercase b and lowercase c. Okay, it's important. Ax and this is C1, this is A square and B square. Okay, I'm done with finding the value of D1. I'll simplify. Don't you think the complete my numerator becomes only C1 whole thing divided by root of A square plus B square. Similarly, using the same logic, I'll find the value for D2. D2 will also be, since again, what's the main agenda between both these lines is, or what's the common objective between both the lines here is, they have the same origin. Okay, they have a same starting point. Starting point is what? The origin, which means the value of X as well as Y is 0. So I'll be using the same perpendicular distance formula. I'll use the same formula. I'll only do a small change here. Instead of writing C1, because I'm trying to find D2, I'll write C2. What's the logic? D2 is nothing but the distance from the origin towards line 2. So a line 2 is represented by L2, which means L2 has C2 in it. Okay, same concept here. So D2 will be A into 0 plus B into 0 plus C2 whole thing divided by root of A square plus B square. Fortunately, I know the value of D2 also. It became C2 divided by root of A square plus B square. I'll pause here. I'll go back to my heading. My heading says, find the distance between the parallel lines. If you see our logic here, our diagram, the distance between the parallel lines is actually given by D2 minus D1. The reason as to why we didn't find the distance directly, the distance between them is because we did not know the direct values or the actual values of D1 and D2. But since after applying the formula, right now we know the values of D1 and D2. I can find the value of D2 minus D1. My agenda here is always to find the value of D2 minus D1 for which D2 and the values of D2 and D1 were required. Okay. Now what I'm going to do, D2's value is numerator. I mean, if you observe properly, don't you think the denominator of both the cases are the same? Which means I'll copy paste the denominator without any change there. A square plus B square. One thing to remember, always put modulus. Okay. In this case, since D2 came initially, D2 always corresponds to C2. I'll write C2 first minus C1. This is my answer. So distance between parallel lines will be able to, they'll be asking directly. This is the derivation. Okay. Now, again, distance between the perpendicular distance diagram, sorry, derivation is also there. We will do it in the next class, not to get confused. But let's solve a question based on this. Fine. Once you look at the question, first try to check if it is a parallel line or not. Okay. If it is a parallel line, you'll be able to get the answer directly just by using the shortcut formula. Okay. Let's go. Let's have the first question. They're asking find the distance between, again, two parallel lines. Sorry, they're asking find the distance between the lines. 2x plus 3y plus 5 is equal to 0 and 4x plus 6y plus 9, plus 2 is equal to 0. This is the set of things given to us. So understand one small concept here. Okay. Check if both of them are the same. They are not looking the same. But if I use my brains little and 1 minute, equation 1, equation 2. If I divide equation 2 throughout by 2, okay, I'll write the letter. I mean, I'll write the words here because you get confused. Equation 2 and 2, that's why. Okay. Don't you think after dividing equation 2, it becomes 2x plus 3y plus 1 is equal to 0. And equation 1 remains as it is. 2x plus 3y plus 5 is equal to 0. Now, if you see, the value of A is the same, the value of B is the same, but the value of C1 and C2 are differing. That's exactly what I wanted. So based on this specific concept, I realized that what I'm trying to handle here is not a regular question, but a parallel line question. So how do you find the distance between the parallel lines? It's given by the formula, modulus of C2 minus C1, whole thing divided by root of A square plus B square. Okay. Obviously, at this point of time, I'm supposed to find the values of individual things. The value of A is equal to 2. The value of B is equal to 3. The value of C1 is equal to 5. The value of C2 is equal to 1. At this point of time, obviously, you'll get a doubt. Is it required to do the step of dividing the second equation by 2? 100% yes. Just imagine if you didn't do it, don't you think you'll be having two values of A and two values of B? If you're having two different values, then what's the whole point of learning parallel lines? So the value of A and the value of B has to be one value, has to be the same. Okay, so try to convert it. And obviously in this case, the conversion was required. Usually it will happen. If it is not happening, then it is not the concept of parallel lines. Remember this. Okay, so you should not have A1 and A2 because again, if I ask you, where will you substitute the values of A1 and A2? It's just A square and B square. That's why. So I write the distance as it is, modulus as it is, okay. Since it is modulus, I mean, I think at this point of time, you realize why I'm supposed to put modulus because you'll be getting a negative answer here, but end of the day, it's fine. The modulus will make it positive. 5 minus 1, I'll write it directly. You can write 1 minus 5 and then make it positive. No worries. Root of 2 square plus 3 square. Correct? 2 square plus 3 square. 5 minus 1 is 4. Whole thing divided by 2 square is 4, 9, 13. Okay? This is my answer. Units. That's how it works. You're always supposed to understand the logic behind it. What are they trying to ask us? Fine. So why am I trying to divide the second equation by 2? I just want one values of A and B. That's why. C1 and C2 has to be different. If it is the same, it is not called as parallel lines. Remember this. You cannot have A1 equals 2, A2 equals 4. No. Again, as I told you, this belongs to the second set of parallel lines where both of them are not the same but are multiples of each other. Getting it? That's the logic. So practice this, practice all the previous recordings once. From Saturday, we'll start off and, we'll start revising the most important concept, obviously, for your upcoming exam, which is, I think, have your Dasara holidays also. Which means during holidays, we will be able to take this, we will be able to finish off whatever is left out. Okay. So yeah, I'll see you.